Okay, let's give you guys some practice. So find the area of this. Find this area here from negative infinity all the way to 0. So from negative infinity all the way to 0. So press pause and have a go. Okay, so to do this, we're going to integrate it from let's say from B to an arbitrary point B to 0. So we are going to integrate it from B all the way to 0, and then later on we will allow B to head towards negative infinity. So our normal routine would be to integrate it from an arbitrary point B all the way to 0, all the way to 0, and then later on allow B to head towards negative infinity. So let's try and integrate this now. So to integrate this, remember we are integrating from B all the way to 0. Later on we will allow B to head towards negative infinity. But the first step is integrate it from B to 0. But in order for us to integrate this, we've got to use the integration by parts formula. So here, allow this to be U, allow this to be V prime. We've done this many times, so you should know how to do this. Well, use integration by parts, and it will give you this. So now evaluate this. So when you put this into here, this would be 0 times this. That would be 0. Put this into here, so that would be your B here. Put it into here. That would be e to the power of B, e to the power of B. And then you've got minus, that's this minus here, and then now integrate this from B to 0. So when you integrate this, it becomes this from B to 0. So put this into here, that will be 1. Put this into here, that will be e to the B. So that will then give us this. That will then give us this. Now tidy this up. So here this. A negative and a negative and a negative, that will give you a positive here, and then blah blah blah, tidy up this bit will then take you to here. Now allow B to head towards negative infinity. Well, now allow B to head towards, well, the minute you allow B to head towards negative infinity, you're really integrating from negative infinity to 0. So the minute you allow B to head towards negative infinity, this thing becomes this. And then this thing, well, you've got to take the limit as B head towards negative infinity. So you're taking the limit of this as B tends towards negative infinity. So the minute you let B head towards negative infinity, this thing becomes this. And this thing becomes this thing. Okay? So, hang on. So now look at this here. As B heads towards negative infinity, if you look at this, e to the power of x looks like this. E to the power of x looks like this. So you can think of it e to the b then. As B heads towards negative infinity, you're heading towards negative infinity. So you are heading towards 0. So this thing here, as B heads towards negative infinity, this thing will be 0. So this thing here will then become this. So now you can break this using one of the laws of limits. We can break into it. So we can evaluate the limit of this. So that's this bit here, and then evaluate the limit of 1. So yeah, one of the laws on limits allows us to do this. So that will then take us to this. Bear in mind that this thing here will be the number 1. It will be the number 1. So that will then take us from here. That will then take us to here. So now we just need to evaluate the limit of this now. Try to evaluate the limit of this. So let's just consider this bit only. Let's just consider this bit only, and then later on we will come back to here and put it back into here. But for the time being, let's just consider this bit only. So if you look at this here, as B tends to negative infinity, if you look at this here, y equals x looks like this. As B heads towards negative infinity, you're going to head towards negative infinity. So this thing here will be negative infinity. Now look at this one here. E to the power of x looks like this. And then as B heads towards negative infinity, you're heading towards, as b heads towards negative infinity, you're heading towards 0. So this thing here is 0. So you've got infinity times 0. That's an indeterminate form. So you can use L'Hopital's rule. Well, before you can do that, you rewrite this as a here you've got a product. Here you've got a product in negative infinity and 0. You've got a product, this thing times this thing. Whenever you have a product, you can rewrite it as a quotient. So rewrite this as this, and we've done this before. So hopefully you can follow this. So rewrite this thing as a fraction, and then now try and evaluate it as b tends towards negative infinity. So this thing here, as b heads towards negative infinity, this thing here will head towards negative infinity. And then this thing here, e to the power of x looks like this. E to the power of x looks like this. E to the minus x looks like this. So now as b tends towards negative infinity, you can see you're heading towards, you're heading up here. So you're heading towards infinity. So here you've got another indeterminate form. So you can apply L'Hopital's rule. So whenever you have infinity over infinity, you can apply L'Hopital's rule. So differentiate this, that will then give you this, and then differentiate this, that will then give you this. Now try to evaluate this now. So this would be 1, but then as b heads towards infinity, where would this head towards? So let's try and understand this bit here. E to the power of x looks like this. Hang on, bear with me. E to the power of x looks like this. Now e to the negative x will look like this. And then you've got a negative here. So a negative version would look like this. So this thing here would look like this. Okay, so now as b heads towards negative infinity, you can see you're going to go down. You're heading towards negative infinity. So this thing here, as b heads towards negative infinity, this thing here will be a very, very big negative number. So it's in the form, it's something similar to this, a very, very big negative number. So that means this thing here will head towards 0. This whole thing here will head towards 0. So going back, so the limit of this here will be 0. So going back to here, remember we were here earlier. So we just said we wanted to concentrate on this bit here. Well, this bit here, we've just worked out that this bit here is 0. So you've got negative 0. This whole thing here is 0. Well, negative 0 is 0. 0 take away 1. That will be negative 1. So your overall answer is negative 1. So this is your final answer, negative 1. So what that means is this. What that means is that this area here, this whole area here is negative 1, all the way to negative infinity. So the whole area here is in a way the same as 1 square here. It has an area of negative 1. So it's kind of strange, but the whole area here is negative 1. Okay.